Hi everyone, so today we're going to be covering lesson 5.5 roots and zeros. Now we have said before that roots, zeros, x-intercepts, and solutions, these are all the same. Okay, roots, zeros, x-intercepts, and solutions are all they have all the exact same meanings. Now there are different types of roots. There are the real roots and the imaginary. Okay, the imaginary. The real can be positive or negative. Now there is something that is very important that you need to know, that the number of roots is equal to the degree of the polynomial, okay, or function. So let's say if we have x to the power of 5 minus 8x to the power of 3 plus 16x equals 0, you will have 5 roots for this polynomial. Why? Because the degree here is 5, which means that we have 5 roots. Now, if they ask you, find the number of positive and negative zeros and imaginary zeros of a function. So let's say they give you f of x is equal to x to the power of 5 minus 2x to the power of 4 minus x and minus x cubed plus 6x squared minus 5x plus 10. In order to find the positive zeros that are possible, so you look at f of x, not negative x, f of x. You look at the number of times the sign changes. What do I mean by that? So this is positive, right? Positive to negative. Here we have one sign change. Do we have a sign change? Negative to negative? No. Do we have a sign change? Yes. So this is the second. Do we have a sign change? Yes. This is the third. Do we have a sign change? Yes. This is the fourth. So we have 4 sign changes in function, the function f of x. Okay? So we have 4. So we write 4 here. Then you subtract 2 from 4. So 2. And you subtract 2 from 2. 0. Let me explain again. So first, you look at the change in the signs. So from positive to negative here. So there's a change. Negative to negative, no change. Negative to positive, there is a change. Positive to negative, there is a change. And negative to positive, there is a change. So here we have 4 times that the sign changed. Now, you'll write 4 next to the possible number of zeros, okay? Then the rule is to subtract by 2 only if possible. So if you only have one sign change, you do not subtract by 2, because how 1 minus 2, you should not do that. Only if you have 3 changes in the sign, or 4 or 2, anything that you could subtract from a 2 and get 0, nothing below 0. Okay? So these are the possible positive zeros or roots. Now, how do we find the possible negative zeros or negative roots? You find f of negative x, okay? But let me explain something before I write what is f of negative x equal to. Whenever you have negative x to the power of an odd number, it would be negative x to the power of whatever that was. Okay, that is odd. So let's say negative x to the power of 7. It will be negative x to the power of 7. But let's say if you have negative x to the power of 2, it will be x to the power of 2. If you have negative x to the power of 4, it will be x to the power of 4. Because remember, the rule is whenever you have an odd number of negative integers multiplied by each other, the answer or the product will be negative. The same thing with variables. Whenever you multiply a variable, a negative variable, an odd number of times, the answer would be a negative. I think it would be better if I kept that on the side. So let us put this on the side, okay? So now that we know that, let us find f of negative x. So it is f of negative x is negative x to the power of 5 minus 2 times negative x to the power of 4 minus negative x to the power of 3 plus 6 times negative x to the power of 2 minus 5 times negative x plus 10. The constants never change, okay? When you change x to negative x. Then it will be rewritten as, remember, odd numbers, the sign will be negative. The sign will be negative. When it's even to the power of an even number, then it will be positive. So here it's negative x to the power of 5. Here it is negative 2 times positive x to the power of 4. So negative 2x to the power of 4. Then here negative x to the power of 3 will be negative x to the power of 3. So negative times negative would be positive. And then here negative x to the power of 2 will be x to the power of 2. 6 times x to the power of 2 is 6x to the power of 2. Then here negative 5 times negative x. Here it is to the power of 1, which is odd, so it stays as negative x. So negative x times negative 5 make plus 5x, then plus 10. Now we have to count the number of times the signs changed in f of negative x, so we can find the number of possible negative zeros. Okay? So let us count them. Is there a change in the sign? No. Is there a change in the sign? Yes, so 1. Is there a change in the sign? No. Is there a change in the sign? No. Is there a change in the sign? No. So we only have 1 time the sign changed, right? So here we will write 1. So the possible number of negative zeros is 1. Why can't we subtract 2 like we said over here? Why can't we subtract 2 from 1? I said here and subtract by 2 only if possible. 1 minus 2 is negative 1, and we don't want negative numbers in this case. So we would just write 1. Now, they also asked about the imaginary numbers. So, we said that the possible positive zeros is 4 or 2 or 1. Is 4 or 2 or 0. And negative zeros is only 1. Now we're going to use a table that looks something like this. Okay. So here will be the positive, here will be the negative, and the last one will be the imaginary. So here, the imaginary. Here is the negative, and here are the positive. So what we're going to do here is make possible combinations between the possible positive zeros and the negative zeros. So the possible combinations are 4 and 1, 2 and 1, and 0 and 1. Okay? And we know that the total number of zeros that are possible is 5, because the degree of the polynomial is 5. As we said here, the number of fruits is always equal to the degree of the polynomial. So you will write here, you will write 5. Okay? Now, for the imaginary, you will find them by adding these two numbers. So 4 plus 1 is 5. Do we have anything left? Any like, how can I explain? So here 4 plus 1 is 5, right? And we know that the maximum number of fruits that we can have, or the number of fruits that we should have in total, is 5. So is there any room left for any more roots? No. So here there will be 0 possible imaginary roots. 2 plus 1 is 3. 5 minus 3 is what? 2. So there are 2 possible imaginary numbers. 0 plus 1 is 1. 5 minus 1 is 4. So we have 4 possible imaginary numbers. Okay? So, as a summary, we have the possible number of positive zeros for this polynomial is either 4 or 2 or 0. For negative zeros, it's either 1, it's only 1. For imaginary, it's either 0 or 2 or 4. And remember, this is an important note to have, that imaginary numbers should, imaginary roots should always be even, okay? So the imaginary should always be an even number of roots or solutions. So keep this as a note. So imaginary should always be an even number of solutions. Okay? Here we have 0, 2, and 4. They are even, right? So this rule is valid. Okay? Or this claim is valid. Thank you for watching. I'm going to be posting a part 2 to this lesson. The reason as to why I'm going to do that, because I realized that this lesson is too long to fit in one video. So hope you benefited from this video. If you have any questions regarding this, what I've talked about in this video, please leave it in the comment section down below. Thank you and have a good day.